Welcome to qnawire.
In problem number 5 of chapter 1, Intros Chemistry, Structure and Properties, we're told a copper sphere has a radius of 0.935 inches. We're asked to determine the number of atoms that this sample contains. So, to determine the number of atoms, one thing we need to determine is mole, and we only know by knowing what the mass is. So, the way to this question is to determine the mass of the sphere, right? So we've been given the density, which I've represented by this Greek letter rho. We've been told that the density is 8.96 per cubic centimeter. And we've been told also that the volume of the sphere is 4/3 pi r cubed. So P is actually the mass over the volume. In order to determine the mass, we just have to multiply the density by the volume, right? So mass is given by density times volume. So we know that the density that we've been given is 8.96 grams per cubic centimeter, right? The volume of the sphere is 4/3 pi r cubed. So we can multiply, this is 4/3 times pi. But here, our radius is in inches. So we have to do some unit conversion here. So since an inch is 2.54 centimeters, so we can convert that easily to centimeters. So 0.935 inches. We just have to multiply this by 2.54 centimeters, because we know for every inch we have 2.54 centimeters. And this is cubed, right? So upon solving this, we're going to determine that the mass of the sphere is 502.73 grams. Now that I'm in the math, all we have to do is determine the moles and then find the number of atoms. So for the number of atoms, you can just find the mole and multiply by Avogadro's number. The mole is going to be given by the mass over the molar mass. So we've just calculated the mass. The mass is 502.73 grams. Divide that by the molar mass of copper, which is 63.546. Then multiply this by Avogadro's number, 0.02 times 10 to the power 23 atoms per mole. So the units for the molar mass is grams per mole. So we can see that grams cancel, mole cancel. We're going to be left with atoms. And this is going to give us 4.76 times 10 to the power 24 atoms.